Hello everyone, I welcome you all gladly back to my channel. Last time in part 2 of this chapter we saw about groups, and before that we have seen about periods. Do you remember? If you haven't, and if you haven't watched it, do watch it. I will give the link in I button above, or go in the playlist of my channel and search for chemistry chapter 1 playlist and see there. Now let's start with part 3. In this part we will be discussing about variation of periodic properties in periods and group, and first variation, that is atomic size, we will be discussing about that. Let's start. Now, periodicity in properties of elements. The modern periodic table, which is an arrangement of elements in increasing order of the atomic number, is based on modern periodic law. Now, what does modern periodic law states? That is very important. It can be asked, you can see this is highlighted. It can be asked what modern periodic law states. It states that properties of elements are periodic functions of the atomic numbers. This modern periodic law states properties of elements are periodic functions of the atomic numbers. Now, periodicity in properties of elements, what does this mean? पीरियोडिसिटी मीन्स ऑकरेंस, बार बार जब कोई ऑकर होता है तो उसे पीरियोडिसिटी कहते हैं. तो पीरियोडिसिटी इन प्रॉपर्टीज ऑफ एलिमेंट्स मीन्स ऑकरेंस ऑफ कैरेक्टरिस्टिक्स प्रॉपर्टीज ऑफ एलिमेंट्स एट डेफिनाइट इंटरवल इन मॉडर्न पीरियोडिक टेबल. थोड़े थोड़े इंटरवल के बाद, वो भी डेफिनेट, मतलब एक के बाद हो रहा है तो हर एक के बाद ही प्रॉपर्टी सेम होगी, दो के बाद रहेगी, तो ऐसे पीरियोडिसिटी ऑफ प्रॉपर्टीज. Occurrence of characteristic properties of elements at definite interval in modern periodic table, when elements are arranged in increasing order of atomic numbers. In the modern periodic table, the definite intervals are after difference of either 2 or 18 or 18 or 32 in atomic number. You must have drawn electronic configuration, right, of certain elements. And you must have seen that when we are writing it, we write 281. 281 is of which? Do you remember? It is of sodium, Na. So 281. So 2 come, 8 come. After that we write 2818. 2818 32. Like this, the as per the element atomic number, it increases. So 2818 or 32 are the definite intervals. Now, periodic properties. The properties which appear at regular intervals in the periodic table are called periodic properties, and the phenomenon periodicity in properties of elements. This definition is very, very important. It can be asked, what do you mean by periodic properties? Or it can be asked, what do you mean by periodicity in properties of elements? If it is asked periodicity in properties of elements, then you have to write the phenomenon in which properties appear at regular intervals in periodic table. And if it is asked periodic properties, then you have to write the properties which appear at regular intervals in periodic table. This you can write, do this video 5 seconds before and hear what I have said and write that definition in your notebook. Now, periodic properties, okay. First is atomic radii, ionization potential, electron affinity, electron negativity, non-metallic and metallic character, density, melting and boiling point, nature of oxides, oxyacids, hydrides. These are periodic properties. Now, reasons for periodicity in properties in periods and groups. Why? What is the reason? First is, after definite intervals of atomic numbers, similar valence shell electronic configuration occur. When similar electronic configuration of valence shell occur after definite interval. Property of elements depend on number and arrangement of electrons in various shells, including valence shell. In the same period or subgroup, increase or decrease in a particular property is due to the gradual change in electronic configuration in the arranged elements. It can be asked, what are the reasons for periodicity in properties in periods and groups? Then these 3 points if it is for 3 marks, 2 points if it is for 2 marks, and like that. Now let's move further. There are uh, periodic properties which we are going to learn. We have 5 which we have in our syllabus. First is atomic radius, ionization potential, electron affinity, electronegativity, and non-metallic and metallic character. Now actually this table should be at the behind of the means chapter, but it is given in middle because this is like summary. Okay, we are going to learn this more in detail, but this is like summary. If you want to read, you can go throughout with it. After completion means like in the last part of the chapter, I will be taking this table again because this is the summary of chapter, I can see. Now atomic size. Now let's read about atomic size. Atomic size, what does it mean? You have been studying from 6th, 7th, 8th, right? We are studying this from lower classes. Atomic size in chemistry. From 7th standard we are studying it. So atomic size generally means the distance between the center of the nucleus and outermost shell. Suppose this is outermost shell and this is the nucleus. Wait, I will draw it here. This is the nucleus and this is the outermost shell. Okay, so center means what? The center of this nucleus, and this is the outermost shell. So from here to here, what is the distance? That distance is called as atomic size. Okay, do you understood this? The distance between the center of the nucleus, not from the nucleus, from the center of the nucleus. Okay, suppose this is the nucleus, so center of that, from here to the outermost shell, it is called as atomic size. So definition is given: the distance between the center of the nucleus of an atom and its outermost shell is called as atomic size. You can see this diagram, atomic radius, that is the same from center of the nucleus to the outermost shell, that is atomic radius. Unit of atomic radii is angstrom unit, means a degree. Like this you have to write angstrom. We have learned this in physics last year also, angstrom unit. Okay, so unit of atomic radii, atomic radius is angstrom unit. Bond length, atomic radius determines bond length, means between two atoms, center of nucleus. Now two factors affecting atomic size. This question always come in question paper also. I have seen it comes many times, so you must learn two factors affecting atomic size. First is number of shells increases when atomic size increases. Of course, if number of shells are increasing, the atomic size will automatically increase. Just think practically. Suppose this is the nucleus and suppose there are two shells now. So atomic size is more, right? From the center of the nucleus, the atomic size will be more. And if I take one nucleus and I make suppose around 4, so from the center of the nucleus the atomic size will be more because the shells are more. So outermost shell, till it is going to outermost shell, the atomic size will increase as the shell increases. So first factor is number of shell increases as atomic size increases. If the number of shells are increasing, the distance of the outermost shell from the nucleus increases. Nuclear charge increases, atomic size decreases. Now nuclear charge increases. What does nuclear charge means? Nuclear charge of an atom is the positive charge on the nucleus of an atom. It is equivalent to the atomic number of the element. न्यूक्लियर चार्ज अगर इंक्रीज होता है तो एटॉमिक साइज डिक्रीज होती है. मतलब ये मान लो नंबर ऑफ शेल्स जो है वो डायरेक्टली प्रोपोर्शनल है एटॉमिक साइज से, और न्यूक्लियर चार्ज जो है वो इनडायरेक्टली प्रोपोर्शनल है एटॉमिक साइज से. तो अगर नंबर ऑफ शेल बढ़ेंगे तो एटॉमिक साइज बढ़ेगी, न्यूक्लियर चार्ज घटेगा तो एटॉमिक साइज घटेगी. ये दोनों आपके फैक्टर्स अच्छे से मालूम होने चाहिए. न्यूक्लियर चार्ज इंक्रीजेज, द इलेक्ट्रॉन्स इन द आउटरमोस्ट शेल आर अट्रैक्टेड विद इंक्रीजिंग फोर्स. सो ये दो फैक्टर्स आपको याद रखने हैं. पहला नंबर ऑफ शेल increases, atomic size increases, nuclear charge increases, atomic size decreases. 2-3 बार बोल लीजिए फिर वो याद हो जाएगा. Trends in atomic size across a period left to right. These are elements. Okay, atomic radius, this you don't have to learn. Atomic radius, what are, but number of shell remains same. Atomic size unaffected, nuclear charge increases, atomic size decreases. In period 2, that is Li has the largest atomic radius and F the smallest.